All right, hi everybody. We are going to try doing the spinach lab, spinach disk lab. I forget what this lab is called. Anyway, this is traditionally the most frustrating lab for AP biology students because it often doesn't work. So there is no love lost here for you guys. I'm going to try to make it work. Hopefully I can make it work for you. Yeah, so let's go ahead and see what we can do. So first of all, I am soaking some spinach leaves. I just bought salad at the grocery store, and I'm soaking them in some distilled water. I want them to be as not floppy as possible. I want them to be as turgid as possible. So I remove a spinach leaf, and I'm going to cut some discs out of it, and we have very fancy tools for cutting discs. This is my tool. This is a straw, and we're just going to use the straw for cutting the discs. So hopefully keys are in the way. Hopefully you can see what I'm doing. So I'm just going to try to find an area of the leaf that does not have very many veins, and then I try to pop it out. Can you see right there? I cut a little circle in it, and now I'm going to try to pop that little circle out. And once I pop the circle out, I need 10 of them per experiment. So I'm going to put them in this syringe, and that will all make sense fairly soon. I tore the skin on this one a little bit. I didn't mean to. All right, I'm going to put that in here. So there's the first one, and I'm going to do 10 of them. Feel free to speed up while you're watching me do the 10 of them. So here's number 2, and it's stuck inside there. So I'm just going to keep going because that's really helpful. Number 3, it's stuck inside. Number 4, oops. Number 4 didn't come out. You can see I've made some holes already. I'm going to blow 2 and 3 in here. There they are. They're in my syringe right now, and I'm going to pop out number 4. I need 10 of them, and I'll blow it in there. Did it go in? It went in, so I have 4 right now. I'm going to keep going until I have 10. So this is number 5. Number 6. I've got 6 right now. Oops. I think one of them blew out back at me. That's no good. I better check how many I have. So 1, 2, 3. I don't know. I can't tell how many I have. Got to have 10. Our math works a lot better if we have 10. So I'm going to pretend I have 5 because I don't know where that other one went. 1, 2, 3, 4, 5, 6, 7. So I have about 6 because I think one of them disappeared. So we're going to say this is number 7 right here. This is the part, well, this isn't the actual part. There's other parts that students have trouble with, but this is one of the parts that students have trouble with. And I'll do maybe 2 more just to make sure I have at least 10. And then 1 more right here. And blow that in. Okay, so I have collected them, trying to aim it at the camera. I've collected all of the little spinach leaf discs. And so now what I'm going to do is add some water. This water has is distilled water with baking soda and a little bit of salt. I even blew some bubbles in it to try to increase the carbon dioxide level inside of the solution. And I'm going to go ahead and pour that in here. I have some from a previous experiment. I have some discs in there that I don't want in there. There, I added a little bit. And now I'm going to slosh it around to capture all of the discs and get them down at the bottom. I'm going to add the plunger. I have to add the plunger very carefully. Otherwise, I'm going to make a big mess. I'm going to let go of my finger. It's going to probably squirt out a little bit because of water pressure. There we go. And I'm going to start pushing upward. And I'm being very careful that I don't smash. Can you see them? There you go. You can see them floating. And that's really important, the fact that they're floating. They're all floating right now. I'm going to keep pushing them up this way toward the top. And basically what I'm going to do is I'm going to try to suck any air that's in them. Remember, during photosynthesis, they're creating oxygen, and they're releasing nope, I'm saying that all backwards. They're releasing oxygen and they're taking in carbon dioxide. So they're full of gas. So I'm going to try to remove the gas. So watch what I do. I'm pushing it right up, all the gas right to the edge. So there's a little bubble of water up at the top. And now I'm going to put my thumb on it. And this is where students make their biggest mistake because it just takes a lot of practice and you don't have time to practice in class. I'm going to pull on the plunger as hard as I can. Can't make it go very low. There, I pulled it one time. What I'm trying to do is to pull any gas that might be inside of the discs out. And now they're jammed up at the top. Let me see if I can lower it. There we go. And I'm going to push the water back up to the top. I don't want any gas bubbles in it. Super subtle how to do this. Okay, and then I'm going to try it one more time. I'm going to pull on it. I'm going to give my little thumb a bruise. And now, I don't know if you can see, but a bunch of them have sunk to the bottom of the fluid that's in here. They're floating around at the bottom. So I'm going to go ahead and pull these out, and I'm going to pour them into the beaker that I'm going to use today. So this is the beaker that I'm going to use for our control group. And I am going to carefully add some liquid in here. That doesn't have any, I've got some spinach discs already in there. I got to make sure they don't get in. There we go. We'll go with that amount of water. And I think a couple got in, so let me reach in and get them out. Got that one out. And I don't want these ones in here because these are used ones. These are ones I already experimented with before I turned the camera on, just making sure I could do this experiment because it's such a hard experiment. All right, so now I'm going to go ahead and add the discs that I worked on just now. I'm going to add them to this beaker of water. And they are supposed to sink, and any that do float, I'm going to remove them from our experiment. So ideally, we have 10 that sink because 10 is an easy number to work with. So let's take a look. And right now, I don't know if you can see, but it looks like there are 10 floating on the floating. That doesn't make sense. They're all on the bottom. So I'm going to bring this over to the window. This is exactly what I was hoping for. I'm going to bring it over to the window. And I'm going to put it, there we go. So it's getting sunlight. They're getting sunlight, but then they're also getting light from my lamp. And what we're going to do is turn on a timer. Oops, I'm going to shut this off for just a second. I got to get my timer going. Okay, so I'm already about a minute behind on my timer. I don't know if you guys can see the timer going. I should make it full screen here. There we go. And what we're trying to do, we're trying to figure out if any of the discs, how long it takes for the discs to float. Typically, it takes about 10 minutes. So you're going to totally fast forward through this. Actually, maybe I'll pause the video for a moment. I'll pause the video just for a moment until they start to come up, and then we'll start the video again. All right, we're getting our first one to float. So we're at 145. And I don't know if you can see this. It's pretty tricky to see, but there is one that's floating up at the top right now. You're supposed to give it a little bit of a swirl. Oh, there's one coming up. Oh, there's a bunch coming up. So give me a second. That is 2, 3, 4. And we're at 2 minutes. So we have 4 up right now. 4 up. I'm trying my hardest so that you could see, but there are 4 that are floating at the 2-minute mark. And now we just got a 5th one at 2 minutes and 20 seconds. Here comes 6 and 7. They're starting to come up. 6 and 7 came up at 2 minutes and 30. Can you see it at all, you guys? I just don't know if you can see it. I'm trying my best. There comes number 9, I believe, and that was at 2 minutes and 40 seconds. And we're waiting to see if we get one more that's still down at the bottom. And see if we can get that last one to float up. And we'll only give it a few more seconds. And if it doesn't float, a few more minutes. And if it doesn't float in a few minutes, oh, it's going. I don't know. I want to put it in an angle that you can see it rising up. Can you see it coming up? There it goes, there it goes. And that is leaf disc number 10. All right, so at 3:18, we got our 10th disc. So you need to write all that data down. At 3:18, we got our 10th disc. All right, now I'm going to set up a new experiment. I'm going to pause it right now and I'll come back. Before I do that, I forgot I wanted to take the temperature of the water because I thought that would be a fun variable to adjust. So the temperature says, let me turn it so you could see it. This is impossible for me to do with one hand here. I don't know if you'll be able to see what I'm doing, but the temperature here says 21 to 22 and a half degrees. So the temperature here, that's room temperature. So 22 and a half degrees is the trial that we just did. Now I'm going to adjust the temperatures. I have a hypothesis. I've never done this. I have a hypothesis that warmer water will speed up the reaction and colder water will slow down the reaction. I don't know. So we're going to try. I'll be back in a few minutes. One more thing before I forget. I think it took me about a minute. I think it took me about a minute to get that timer started this time. So how about you add 1 minute, sorry, to all of your results. So let's say it took 1 minute longer than it actually did. That is not good science, but I can't do this experiment over and over again. It's too hard for just one person. All right, I'll be back in a moment. All right, we're starting again. I have already cut up 10 more discs and placed them in here. I'm going to redo my experiment. So I am going to pour some of this solution. This is the solution that has a little bit of baking soda and a little bit of soap in it. Add it there. I'm going to put in my plunger. And remember, the point of this step is to try to remove any air that is already existing, any gas that's already existing in the spinach circles, so that they will sink. If there's any oxygen or carbon dioxide in them, then they will just float. And you can see that they are floating in this solution right now. I haven't really removed the air from them yet. So I'm going to push it all the way up to the very, very top. So you can see the water go right up till there's a little bubble. I've got to be super careful not to damage the spinach. Okay, I'm going to plug my thumb and I'm going to pull really hard. Okay, I did it one time. I'm going to see, yep, I can see some of them are starting to sink. I usually like to do it twice, although I'm always afraid of damaging them. So I'm going to push the water back up right to the top. Do it one more time. A quick pull. Good enough. Okay, and now hopefully all of them have sunk. Looks like they're sinking. Okay, so now what I decided, my experiment, you guys could have done anything. I didn't know what you wanted to do, so I decided to try temperature. So right now I have my solution that is baking soda and soap. I have that solution warming on a hot plate. I'm going to go grab that solution. I'll pause. Don't worry, you don't have to wait for it. And we're going to try it in a warmer temperature and see if that speeds things up. That's my hypothesis. I honestly don't know if it's going to have any impact on our results at all. And then we'll try a cold water trial. I'm going to jump in and tell you a little bit about my reasoning really quickly. So when I heated it while I was working on something else, the temperature, I'm trying to turn it so you could see it. The temperature got up to 50 degrees Celsius. That's about 100... I can't do it in my head, sorry. But it's really quite warm, and it's warm enough to denature the proteins that are in the leaf. So remember that, like, if you have a fever that's over 108 degrees Fahrenheit, it can cause your proteins to cause the tertiary, the secondary, any of those hydrogen bonds. It can break those hydrogen bonds and it can cause it to change shape. And anytime that a protein changes shape, it doesn't function. Well, there's bajillions of proteins involved, enzymes involved in the process of photosynthesis. And that's not what I was trying to go for. I don't want to denature the proteins in the leaf because I think that that for sure is going to stop photosynthesis and that I'm going to have zero leaves that float. So I wasn't hoping to get it really hot. I was just hoping to increase the temperature a little bit. It was only at 22 degrees Celsius. I was imagining maybe 30 degrees Celsius, just a little bit warmer, to see if that speeds up the molecules that are interacting. So I'm going to let it cool down a little bit before I run this experiment. And we'll try to run it at 30 degrees Celsius. All right, I'm going to go ahead and start. The temperature has gone down to about 39 degrees. 37 degrees, I think it's 37 degrees, is what human body temperature is. So, yep, 37 degrees Celsius, of course, is what human body temperature is. So, the proteins shouldn't denature at this point, so I should be able to use them. I'm going to go ahead and pull them out of the syringe. So, I'm going to lower this a little bit so you can see what's going on. I'm going to lower the beaker, pull these down. And if any of them are floating, I'm going to remove them from our calculations. Put them all in there and let's take a look. Let me just see if they're all sinking. I don't know if you can see. Oh, there's one that's thinking about floating. I think, ladies and gentlemen, that a couple are thinking about floating, but not yet. Okay, let's walk them over to the light in the window and we'll start our timer on time this time. I won't screw that up. Gosh, this is just too many things for one person to try to do. Too many things for one person to try to do. All right, so remember we've got warm temperature here. I'm going to go ahead and hit start on the timer. So you see the timer going. And I can already see, I hope that you can see these. I can see them floating around a little bit, so it wouldn't surprise me if they come up really fast. If you could see that, but we have the first one just floated at 110, and that is the correct time this time. We have one that's considering floating. Oh, there we go. There's number 2 is at 121. Here comes another one. And another one. We've got 3 and 4 at 132. 3 and 4 came up at 132. I'm trying really hard to let you see this. Oh, number 5 is up at 144. One of them fell down. 6 went up at 149. 3, 4, 5, 6. Yep, I have 6 floating right now. That one took a dive and then it came back up again. So we'll call that one number 7. And number 7 is at 203. We're waiting on 3 more. I hope that you can see this. I'm sorry that I don't know if my camera is aiming at it or not, whether you can see it. So you're just going to have to trust me. We're waiting on 7, 8, and 9. And I see one is taking off right now. It's about to go up. So that is number 7, and the time is 2:29. Here comes number 8. It just made it to the top. So 8, actually, that's 8 and 9. So that was at about 2:38. 8 and 9 made it at 2:38. And then number 10 is on its way up right now. Very slowly making its way up. And number 10 made it to the top at 2:55. All right, so we've got all 10 of them in warm water, and I think that was actually faster if you add on the extra minute where I didn't have the timer on for the first time. So it'll be fun to look at the data on that. I didn't write anything down, so I'll have to pay attention. Now I'm going to try it in a cold water trial. I'm only doing one trial, guys. This is a super huge flaw with my experiment. I'm just doing one trial of each temperature. Not enough. All right, I'll be back with some cold water. All right, everybody, I'm back with the cold water. I've got it down to about, it looks like 11 degrees right now. I had it in the freezer and whatever, trying to cool down the temperature a little bit. And I used some cold water in here also. I'm going to push it out and do the same thing. Remember, we're trying to suck any gas that might be trapped inside of these. Got to get those air bubbles out. Can you see there's an air bubble right there? I'm going to squirt it up. It's going to make a little squirt. There we go. Okay, and now I'm going to suck the gas out of them. It's really hard to do, if you can tell by my grimacing. All right, and then we're going to push any air bubbles back up again, and we're going to do it a second time. Get the air out. And then I'm done. And hopefully, maybe you can see that some of them are sinking down. There's one trapped in the thing, but I'm guessing looks like it's sinking down too now. So we're good to go. All right, so I'm going to go ahead. Oops, I need to clean out my beaker. Hold on just a second. back again. There were a few stray little discs from the last time I did this. So now I am ready to add my discs in, and the temperature this time is right around, I'm going to say 12 degrees actually, because I've been wasting some time. So it's probably not quite as cold as when I first did it. And I need to make sure that they all sink, and I'll pull out any that don't sink. I need to make sure that everybody has sunk to the bottom. And it looks like nobody's floating, so we're ready to go do the experiment. So let me walk over with you to the window and the light. Oh, it's awkward. Watch me drop something. It'd be bad. Okay, let me set it in the light here. And I need to start the timer. Turn it this way so you can see it. So let's go ahead and start the timer. Timer's going. And this is the boring part. It takes, the reason I hypothesized that cold water was going to do this, I didn't expect it to be this extreme, is that we know that temperature is a measure of how fast molecules are moving. So I was assuming that if we warmed up the molecules, they'd be moving faster and allow more chemical reactions to happen faster. So that's why I expected photosynthesis to increase. And if I let it cool down, it would slow down. But the thing I thought I would mention to you is just the idea of hypothermia, which is what Minnesotans get in the winter sometimes if we get super cold. And what's interesting about that is that it's not damaging your proteins. Remember, high fever damages your proteins, and it's almost impossible to come back from that, to recover from denatured proteins. But when it's cold, it's not damaging the proteins. It's just slowing down the rate of the reaction. And so a person who is hypothermic, they're not using oxygen correctly. They're not metabolizing anything correctly. And so everything is just going slower and slower. Nothing's broken, just going really slow. But eventually you need more oxygen than your body is able to produce, and your mitochondria are able to produce. And eventually hypothermia becomes deadly. But it doesn't damage anything. So if we catch somebody who is hypothermic, in time, we can warm them back up, and then they're totally fine. They can survive it without damage. Finally, we got one that's going up. It's very slowly moving up, and the time is 20:27. So one has made it to the top. It's probably super hard for you to see, but you just have to trust me that it's there. I'm going to pause again, and I'll tell you when the next one pops up. 20:27. Okay, some are changing. Here's our time. And we've got 2 and 3. Can you see them going up? It's not quite time yet, but give them a second. Give them 5 minutes. I cannot believe how long this is taking. Oh my gosh. I did not expect this experiment to last all day long. Okay, so that's numbers 2 and 3. That's numbers 2 and 3, and they're almost to the top. We'll get a time in just a second. Oh my gosh, can you believe how slow they're moving? If this is not convincing about how slow molecules move. So let's go. I'm going to go ahead and call it at 2 and 3. So we have 2 and 3 at 23:27. Now I'll pause again. We've got 4 and 5 on the move. They're starting to come up, but they're going to take forever. Hopefully you're fast forwarding. I've been sitting in this window the entire time. Oh my gosh, what am I doing? I have so much grading to do, and I'm sitting here watching leaf discs float. But we've got number 4 is almost to the top. And I'm going to call it at number 5, and I'll explain why a little bit later. As long as you get 50% of the discs, you're good. So we're going to say leaf disc 4 is up at 24:43. Actually, several of them are coming up right now. You can see them very slowly. Maybe you can see them. I hope you can see them. I'm trying to make it so you can see them moving around a little bit. This is arguably the world's most boring video. The most boring video you've ever seen in your life. Okay, I'm pausing. As soon as I see them actually move. Number 5 and 6 are rising up in the most boring race for the top that I've ever seen in my life. You've never seen anything move so slowly as these little leaf discs. I hope you can see them. So 5 and 6 are on their way up. Actually, 7 has stood up. Once we record 5, I will pause us. As long as you have 50%, we can mark it as good enough. Wow, this is quite a race. And almost to the top. Number 5, I'm going to call at 27:10. And number 6, I'm going to call at 27:17. All right, we'll stop it there.